Alright, kia ora boys, this is actually attempt 3 at this video, so excuse me if I sound a little bit tired, and what if someone interrupts because I've taken so long. So what we're trying to do now is find out where the intersection between pairs of graphs. Okay, so we've got two graphs here, we've got a parabola, which I think I've written over here as the red one, and a straight line, which is the blue one. So here they are here are these two graphs. We're trying to solve where these two graphs intersect. So what we're talking about is that one there and that point there. Obviously this point here has an x and a y value, just like this one here has an x and a y value. So what we have to do is solve for both. How do we do that algebraically? Because Desmos will give us that answer straight away. So algebraically, what do? Well, we say that this x value, this y value and this y value are the same thing. So we are saying they are the same as each other, which means we can write down, x squared is the same as 2x plus 7. That there forms a quadratic equation. If we've got a quadratic equation, what do? We make it equal 0. Once it equals 0, we could factorize, complete the square, use a quadratic formula. Okay, I'm going to use a quadratic formula just to reiterate a few things. Okay, so a is 1, b is -2, and c is -3. So using the quadratic formula, which is, remember this is given to you. So that, what I'm going to do now is just substitute those values in. And remember, I use brackets to highlight where I am putting my A's, B's and C's. Hopefully that's right. Pushing the delete button on my pen. Once I get my calculator out, hopefully that'll tell me that that is going to be 2, it's going to be going 4 minus positive 28, sorry, 4 minus -7, that's positive 28, all over 2, so it's going to be 2 plus and minus the square root of 32 over 2. If you're just confused with what I was just saying there, I was trying to go -4 times -7 is positive 28 in my head. I just couldn't communicate that verbally very well. So in my calculator now, I'm going 2 plus root 32 divided by 2 equals 3.83. So I'm going to get as x equals 3.83. Go back through my calculator and make it a minus, which is -1.83. So x equals minus -1.83. Hopefully those are the numbers I said. But remember, you needed x and y. A little shout out to my son there. When x equals 3.83, y equals 3.83 squared, because I can put it into either of these two equations. I've just said that one there is the easiest one to put it into. So when x equals the 3.83, 3.83 squared is going to be 14.66. So 14.66. That forms a coordinate for 3.83, 14.66. The other coordinate is when x equals -1.83, y is going to be -1.83 squared. Go back to my calculator. I'm just going back to my solutions and then going that number squared. You don't have to do that for right now, but it's best to if you can. 1.34, which gives us 1.83 and 1.34 if I remember rightly. So what we're saying now is that this point here must be that one there, because it's roughly -1.8, and that one there is that one there. So if we go along to Desmos, Those were my answers. Those are what I got. So that's what we're doing today. Okay, there are 2 more questions here, 1 and 2, because there's different styles of questions with regards to the discriminant that we've been doing. If you remember back to the discriminant, we can get it where it's positive, which gives us 2 solutions, as in the one above. We can get the discriminant equaling 0, which gives us 1 solution, or we can get the discriminant less than 0, which gives us no solutions. Okay, so what I'll quickly do is I'll quickly run through these ones with less of an explanation, but hopefully you can follow. So one equation equals the other. Set it up so that it is a quadratic equation where it equals 0. Where it equals 0. So what we're trying to do is I'm trying to look for 2 numbers that can factorize to multiply to 4, add to -4. So that's going to be x minus 2 and x minus 2. So that gives me a solution. My computer is... Alright, I just closed down one note because it was playing up on me. So this tells me x is 2, or 2, which therefore, so x is just 2. Okay. If I'd gone through the quadratic formula for this one, what I would have got is x is negative minus 4 plus and minus the square root of negative 4 squared minus 4 lots of 1 lot of 4 all over 2 lots of 1. Hopefully you can identify there that 16 minus 16 is 0, so I get that discriminant is equal to 0, which tells me the graph is one of these ones where the just touches once. So the intersection of those 2 graphs is a tangent, which is quite important for later on in calculus. Carry on finishing this algebraically, I could say at x equals 2, y equals 4 lots of 2, which is 8. So therefore that coordinate is 2, 8, which you can see there is 2, 8. Okay, which I can go over to Desmos and I can prove that's 2, 8. Okay, so this straight line here is actually a tangent to this parabola. Okay, it catches it once, which is quite important when you think about a different context that we're going to come up to soon. So if you think about that, we've done that one, we've done that one. Have we done that one? AKA right now. So algebraically, what does this look like? You still set that up and that up to be equal to each other. You still rearrange those equations to be equal to 0. You can still use the quadratic formula. You can still try and factorize it. You can still use the complete the square method. But generally, the quadratic formula is going to be easy to notice with these ones. Okay, so x equals minus b plus and minus b squared minus 4ac all over 2a. So that's negative 2 plus and minus 2 squared minus 4 lots of 3 lots of 2 all over 2 lots of 3. Now, running out of space, I'll do it up here to keep the question in the frame. Negative, so that's going to equal negative 2 plus and minus the square root of 4 minus 4 times 3 is 12 times 2 is 24, hopefully. All over 6. So hopefully you can now see that's going to be equaling negative 20 under that square root symbol. Now, remember when we go back to our graph, our calculators, just going to try and move that. Alright, just move that. So it's going to be, when I put this in my calculator, minus 2 plus the square root of negative 20 divided by 6. It gives you a no real error. So this means there is no real solutions. And remember, the reason why isn't this divide by 6. It isn't even the fact that that's a minus 2. Strip all that away, it's that part there. it is this part here that gives you no real solutions. Graphically, what does that mean? Go all the way over to my graph. It means that these graphs do not intersect. Okay, and if the graphs don't intersect, then there's no intersection between them. So that's what we're going to look at today. Okay,